Hello everyone, welcome back to BZC Warriors. Let's begin our today's class. Before that, I want to tell you one medical fact. A man from Nagpur suffering from a rare disease sleeps 300 days a year. What you are hearing is true. Doctor said that he has hypersomnia. Once he sleeps, he doesn't wake up for 25 days. Here we have to understand the disease hypersomnia. Hypersomnia matlab excessive sleepiness. Insomnia, it is also one type of sleeping disorder. Insomnia means sleeplessness. Which type of disorder he have? Hypersomnia. So this is the fact. Let's begin our today's class. Here main heading is colligative properties. These are the types of colligative properties. We have to, first of all, we have to understand what are colligative properties. The properties of a dilute solution which depends only on the number of particles of solute present in the solution, but not on the nature of solute. Nature of solvent are called colligative properties. It may also depends on concentration particles. The definition I mentioned is too long now. Now I will say in simple words to understand. Which depends only on the number of particles of solute is known as colligative properties. Remember it. There are four types of colligative properties. Relative lowering in vapor pressure, E.B.P elevation in boiling point, D.F.P depression in freezing point, and finally O.P osmotic pressure. Let us start with R.L.V.P, relative lowering in vapor pressure. R.L.V.P का definition क्या है? When non-volatile solute dissolves in volatile solvent, its vapor pressure decreases. Here we have to understand what is volatile and non-volatile. Volatile substances that have a tendency to vaporize. Therefore, non-volatile is they do not have a tendency to vaporize. Listen carefully. When non-volatile solute dissolves in volatile solvent, its vapor pressure decreases. Now I am going to explain in now I am going to give a correct explanation for you. On adding a non-volatile solute, the vapor pressure of liquid decreases because of the solute particles occupying some surface area of the liquid solvent. Which is occupying of solute particles? Some surface area of the liquid solvent, resulting in lowering of vapor pressure. Now we will check in mathematically. Vapor pressure is equal to partial pressure. PS what has come? PS is equal to P naught A XA. XA what should I write here? P naught A 1 minus XB. Solve this. PS what has come? PS what has come? P naught A PS what has come? P naught A minus P naught A XB. Now you have to change this. P naught A XB to this side, PS to this side. P naught A XB is equal to P naught A minus P naught S. XB what has come? P naught A minus P naught S by P naught A. Its name is relative lowering in vapor pressure, R.L.V.P. And what is P naught A minus P naught S? Lowering of vapor pressure. Lowering of vapor pressure. P naught A minus P naught S by P naught A. Its name is relative lowering in vapor pressure. They ask a similar question to confuse on the exam. Lowering of vapor pressure is a colligative property. It is not a colligative property. Relative lowering in vapor pressure is a colligative property. Relative lowering vapor pressure is a colligative property. It is not colligative property. They also ask like this, which is a colligative property? In options they given P naught A minus P naught S, and another option is P naught A minus P naught S by P naught A. Now you have to choose on this one, P naught A minus P naught S by P naught A. It is a colligative property. Relative lowering in vapor pressure is a colligative property. Here P naught A minus P naught S by P naught A is always equal to mole fraction of solute. Relative lowering in vapor pressure is always equal to mole fraction of solute. So this is about the R.L.V.P. Now we will move on to the E.B.P, elevation in boiling point. Just now only we completed the R.L.V.P. Now come to the E.B.P, elevation in boiling point. It is similar to the relative lowering in vapor pressure. Now I will tell the definition of E.B.P, elevation in boiling point. When the non-volatile solute dissolves in volatile solvent, its vapor pressure decreases. Thus boiling point increases. What will increases? Boiling point will be increases. Example, have water. मेरे पास बेहतरीन पानी है. Put solids in it. मतलब non-volatile solute. Put non-volatile solute in it. Now I will explain this with the graph. So this is the graph. Vapor pressure versus temperature graph. Its name is pure solvent and its name is solution. What? Solution. And the vapor pressure of pure solvent will be high, solution will be less. प्योर सॉल्वेंट का वेपर प्रेशर ज़्यादा होगा, सॉल्यूशन का कम होगा. इफ़ आई ड्रा ए लाइन हियर, this is 1 atm line. Vapor pressure made 1 atm line. Here the cut points will come and here the cut points will come. When the vapor pressure made 1 atm line, the temperature at the same time, what do we call him? What do we call? TB naught and TB. If this line starts moving forward, TB naught is greater than TB or TB is greater than T naught B? TB is greater than T naught B. TB is greater than T naught B. T naught B represent elevation in boiling point of pure solvent. And what is TB? Elevation in boiling point of pure solvent plus solute is known as TB. Delta TB, elevation in boiling point, is equal to TB minus T naught B. Its name is elevation in boiling point. मतलब boiling point will increases. And delta TB is directly proportional to molality. And delta TB is equal to Kb into molality. Already you know the formula of molality. Molality formula: number of moles of solute by weight of solvent in kgs. Weight of solvent in kgs. On this whole chapter, A means solvent, B means solute. Remember it. And what is Kb? Kb for H2O is equal to 0.52 Kelvin kg or mole. They are given in the questions. Kb for H2O is equal to 0.52 Kelvin kg per mole. Remember this one. Actually, what is Kb? Molar elevation constant or ebullioscopic constant. and Kb is equal to, how can we find Kb? Kb is equal to R T naught B square by 1000 latent heat of vapor pressure. R represent gas constant, T naught B standard of boiling point pure solvent, and LV latent heat of vapor pressure. So this is about the E.B.P elevation in boiling point, and that's all for today.